Alright, next up we're going to work with adding or subtracting rational expressions with unlike denominators. For example, this is back with just the normal numbers. You could have 3 fifths plus, say, 4 sevenths. Now, to be able to add these together, you need to have a common denominator, and right now we do not. So what I look for is the least common multiple of 5 and 7, and that gives us a number, 35 in this case, that we call the least common denominator. Okay. Now, the reason why I want to know that least common denominator, what do I need to multiply by 5 to get to 35? Well, I need to multiply by 7. But if I do it to 1, I do it to the other. So both the numerator and denominator get multiplied by 7. Now, for the fraction with the 7 in the denominator, I want to get that to 35, so I have to multiply it by 5. And if I do it to the denominator, I do it to the numerator. So I end up with 21 35ths plus 20 35ths, which comes out to be 41 35ths. And I can reduce it if I'm able to, but I don't think I'm able to reduce that at all. So that's the idea. We got to figure out what's missing from each denominator to find that least common multiple of them, or the least common denominator, and then multiply by that. Let's go ahead and take a look at it here with example 5. I have two denominators, t squared minus 2t minus 3 and t minus 3. Well, t minus 3 is already factored. That makes my life a little bit easier. Let's go ahead and factor t squared minus 2t minus 3. So I need the product to be negative 3 and the sum to be negative 2. How about negative 3 and positive 1? T minus 3, t plus 1. Now, if we take a look here, what's missing, the t minus 3 is in both denominators, so we're good. But the second denominator needs a t plus 1 term. So it just would be like it needs the 5. I need to have the 5 to multiply by the 7 to get the 35. That t plus 1 that I'm missing is what I need to multiply by. So I'm going to have 3t plus 2 over, and I like to leave it in the factored form here, t minus 3 times t plus 1 plus t plus 1, put it in parentheses, t minus 3, put it in parentheses, and I need to add in that part of the denominator that's missing, t plus 1, t plus 1. Now what do I get? I get t minus 3 times t plus 1 in my denominator. 3t plus 2 plus, well, I have t plus 1 times t plus 1 is t squared plus 2t plus 1. Now I can combine like terms, and you'll notice I have a 3t I can add to a 2t there, and a 2 and a 1 I can add together. And I have t squared plus 5t plus 3 all over t minus 3, t plus 1. Now, the last thing I want to do is double check, can I factor the numerator? And sometimes you can. In this case, I want a product that's 3 and a sum that's 5. Well, I can only think of two numbers that multiply to be 3 that are whole numbers. That'd be 1 and 3, and their sum is not 5. So, too bad, we can't factor that there. So that becomes our term, our final rational expression. You do want to check to see if you can factor it, because sometimes you can factor stuff out, and that's pretty handy.